We go now to the third presentation. Edward Su is the Chief Product Officer at Rescale. The title of the presentation is High Performance Computing Built for Cloud Using an Intelligent Control Plane Approach. Yeah, Edward, please.
Awesome, thank you. Can you hear me? All right, fantastic, great. So my pleasure to speak with you all today about high performance computing built for cloud. I've been here at Rescale for about 2 years at this point, and prior to joining Rescale, I've served a variety of marketing and product leadership roles at container infrastructure companies, companies like VMware, and led engineering at Oracle. What I wanted to discuss with you all today is really about the type of innovation that researchers and engineers really excel for us in our society. Right? There's two main types of technology innovations, I would argue. Cloud computing is touching both of them. But the way cloud computing has been applied has actually been very asymmetrical between the two. Right? The two major types of technology innovations that occur, that we contribute to, are, of course, technologies that connect us. Those are things around e-commerce, social media, all fall in that category. And then there's the other aspect, which is how are we building things that improve people's lives, right? In terms of connecting us, social media, Netflix, Airbnb has really changed how we live. But at the end of the day, you're still using the same Airbnb, Uber, Twitter, are just new ways of renting cars, renting homes, and sending messages, right? But what about the things that we built? How has that changed in the last couple of years? And how has cloud impacted it? And the short answer is, until fairly recently, not much. The most popular vehicle here in the United States, the Toyota Camry, we made improvements in efficiency, safety, but it hasn't really disrupted our life the way that a lot of the connected innovations that we've seen. And the reason for this is actually quite simple. The problem to solve, to get a high-performance computing stack built in the cloud is actually very hard. But today, I'm happy to share that we're making tremendous progress in this. Today, high-performance computing built for cloud is powering small startups that are like bringing back supersonic travel. Boom Supersonic, one of Rescale's very early customers, recently signed a deal with United to buy supersonic passenger jets. Another one of our customers, Commonwealth Fusion Systems, is looking to bring back, develop for the first time commercial fusion power and get to commercial viability sometime in this decade. From Samsung Foundry, they've been making a lot of strides in bringing electronic design automation towards something that's a lot more collaborative and seamless through cloud collaboration. And then finally, bio-nanogenomics, one of the more exciting startups in these days. What they do is take your DNA strands, pull them out, and do analytics on the DNA to look at how chromosomes are actually failing or causing issues to occur. So what you're seeing on the bottom right there is an analysis of ovarian cancer. And using high-performance computing built for cloud, using Rescale, they're able to unleash the power of cloud computing architectures and resources to tackle those challenges. Now, the reason why so many of these companies are able to take advantage of cloud computing is not just because HPC is now accessible in the cloud. A lot of the components have been accessible in the clouds for some time. The challenge is, how do we solve the complexity that scientists and engineers need to address for them to make a HPC-based solution more viable? Today, if we look at the amount of workloads that are done in the cloud, if you're in software development, almost everything's available in the cloud, right? If we wanted to build a next-generation social media company, everything's available. But if you wanted to do science or engineering, it's actually really challenging because you need a couple of different key pieces. First, you need the number of specialized architectures that might be unique to the thing you're trying to solve. If you're trying to do CFD, FEA, or biomolecular dynamic simulations, they all require different architectures for best performance and most cost effectiveness. Secondly, a lot of the software that you want to run to make this effective is actually in the cloud, not easy to install because a lot of the software vendors that are behind these simulation vendors technologies have licensing that's more used to perpetual on-prem model. And so what we have to do is find a way to not only automate the software, but automate how you do the licensing and management and so forth. And then lastly, the scientists and engineers we serve are not computer scientists, right? So they need a lot more of a turnkey solution so that engineers and scientists can really focus on their work. And I'll give you a flavor of what that looks like. Today, if anybody ever told you specialized architectures are not available in the cloud, that's no longer true, right? Whether it's the most advanced supercomputing architecture to something more basic, cloud providers have done a fantastic job making sure those architectures are easily accessible. But the challenge, of course, is it's not just about the hardware. If you think about the ways to run high-performance computing, there's a couple of high-level concepts that I like to lay out with you. First is to basically do it yourself, right? And I'll give you an example of what this looks like in a minute. This is basically taking cloud provider architecture from Amazon, from Google or Azure, and then pulling together everything you need to make sure that high-performance computing stack is available for you. The second approach is, of course, use a cloud, a software provider-specific cloud solution. That's certainly a viable option if your company's only using software from one ISV, as an example. And the third approach, an approach I'd like to explore further with you today, is this control plane approach. This is one where you take advantage of an intelligent computing platform that has intelligence both northbound and southbound, and have that integrate with any hardware, any cloud provider, and work with any software, open source or commercial. And this is what I like to explore a little bit with you today. And that's what Rescale is. We're not a cloud provider. We're not a simulation software vendor. We're this control plane, this automation layer to make sure that scientists and engineers can get any software they need on any infrastructure they want to be able to run on. And the reason why this is important is because solving science and engineering problems properly does require a breadth of architectures. It does require making decisions around when you want to solve for time to solve, fastest time to solve, versus lowest possible cost. And for our customers in many different industries, the balance can be very different based on specific projects, for example. And in terms of the capabilities we bring to bear, I'll walk through in three major steps. The first is we help customers automate their way to cloud. Right? So if you want to run simulations, whether it's to solve science or engineering problems, we have the full stack management to make sure that applications and infrastructure is available for your turnkey. Secondly, we want to help you get the best performance, right? So that you're making the best decisions around security, around cost performance, as well as administration. Then lastly, it's all about getting the infrastructure and the software out of the way so scientists and engineers can focus on the work that they do. So let's walk through each of these. On automation, this is an example of what it looks like to run high-performance computing in the cloud if you're doing it the DIY way, which I talked about earlier. These are the steps, right? So ideally, you are familiar with AWS or Azure. You understand Linux. You understand how to set up VPCs. You understand how to set up storage environments. You understand how to manage quota, set up SSH keys, install things like parallel cluster, install things like ANSYS, which is a very popular simulation software, which I'm sure all of you know about, and then manage all the dynamics between all of these things. From a Rescale perspective, our goal is to automate this away so that you're just looking at basically a few things. If you know how to use a browser and you know how to use the simulation software you want to use in cloud, you're actually all set. Right? All you have to do is sign in, choose the software you want to run, put the data down that you want to run through the simulation, and then download it when you're complete. And here's some screenshots of that. Right, choosing the software is actually quite straightforward. At this point, we have about 700 or different pieces of software. You can upload your data along this basic workflow. We have other workflows that are available on our platform, as well as different ways of choosing licensing models. And many of the software on Rescale is available on demand because we have a relationship with some of our simulation software vendor partners. So you don't even have to buy licenses because you can buy licenses through Rescale. If you have your own licenses, put those keys in and we'll automate the management of the software and licenses for you. And make sure that you don't go over what you're entitled to from a licensing perspective. So to recap, any software you need, completely automated, on any type of architecture you want. This is a high-level view of the various architectures available on Rescale. Some people like to talk about this as imagining you have the keys to Jay Leno's garage. Use any car you want to solve whatever science and engineering problem you're after. And then lastly, doing this in a very contiguous way. So that's how we help you automate your way to cloud and get the most out of resources available from the cloud. The second piece around optimization, this comes from the fact that Rescale is this automation control plane layer. So we know how much you're spending, we know projects you're focused on, we know how long the jobs took, we know what other hardware is available out there and what the likely time to solve is versus cost would be, and help you make that trade-off between whether you want to solve faster or run a tighter budget. We have ability for you to set policies so they can make sure that these engineers can run whatever architecture they want. These engineers over here can only run templates to make sure they're doing things according to plan. And it really gives you the best of empowering engineers and giving IT, HPC organizations control. And the reason we're able to do this is our intelligent control plane is always analyzing and collecting information about the simulations that are being run. What you're seeing on this page is how we think about performance management. It's a combination of the performance index for that particular architecture, the cost of that architecture, and of course, the maturity of that infrastructure. Right? So in this example, on the on the middle here, AWS oftentimes most scalable in most situations, right? Because they're the largest and the longest running cloud provider. Oracle has made a lot of investments on cloud-based bare metal infrastructures. So oftentimes they do really well in performance, and they have a stated goal of being a very cheap infrastructure provider that comes right across. And then Azure is somewhat of a balance of the two, really focusing on the enterprise and providing high-performance specific architectures. And all of this is actually very transparent from Rescale. You can see directly from our platform, what are those cost and price performance trade-offs, and then basically just through a mouse click, choose one cloud provider or another. Because we are a multi-cloud platform, all this is entirely automated for you. So lastly, on the intelligence computing and empowerment, the key point here is that with Rescale, you're not just doing old school high performance computing, where you have to know what a scheduler is, where you have to know how to set up clusters, where you have to know how to put your job into a queue, right? In the old world of traditional computing, HPC was really about, here's some servers we bought, either on-prem or in the cloud, and then you guys make your submissions, and let's figure out how to make sure we get the highest utilization. IT pats himself on the back for high utilization, while scientists and engineers wait around for low fidelity analytics. That's not good for anybody, right? So the approach we want to take is to be more end-user centric. There's a lot of information we know from our platform. We know the R&D context. We know what projects are in place. We know what templates should be used because you guys have built that. Other scientists and engineers have built it. We know the overall context from a performance perspective, from a budget perspective. We also know the various architectures that are out there and whether or not there's a more performant one for you that will save you money, right? And of course, we know from a business perspective how much this project is spending on R&D computing resources versus others. So providing all those tools, putting it all together so that the researcher can just focus on running their simulations is really how we're really helping. As an example of that, here's a screenshot of the Rescale platform with regards to templates that are available. You can see that here. All an engineer has to do is log in and put in their data because some of their fellow engineer has set up the templates for them so that the software, the licensing, other aspects of the configuration, other additional simulation data that needs to be always used is also part of the template, right? So you can just focus on the science. And the net of all this, why is this important? It's because by doing this, we're able to get to a high-performance computing that's built for cloud, taking advantage of all aspects of cloud. Cloud's scalability, cloud's various architectures that are available, and cloud's connectedness, right? So that collaboration and innovation can move a lot more quickly, right? In the old world, you would start off with the hardware. You buy that hardware, and for 5 or 6 years, it's having implications on how your users are working, what software you're running, and how well they're running. Well, we at Rescale think that should be different. You should start from the user, go to the application, and then choose the right architecture for that app at any given point in time. So the best architecture today may not be the best architecture 6 months from now, because maybe one of our cloud provider partners has created a new architecture. And by making all this seamless for our customer, we can really help them focus on just doing the science and engineering and not the infrastructure. And so that's all I have prepared for today. The goal at Rescale, basically giving you this ability to run high-performance computing that's not just in the cloud, but built for cloud and optimized for cloud, taking advantage of scale, various architectures, and connectedness for the fastest possible innovation possible. I think that's it. Thank you for your time, and If there's questions I can take, I'm happy to do so.
Thank you very much. Perfectly in time. You have still 50 seconds just for questions and answer. Let me check on the chat. Yeah. So for environments, for HTTP environments, yeah, and those you presented here, usually a big, I would say, disadvantage are the data. Yeah, so you have to deal, especially nowadays when we are talking really about large amounts of data. So the intelligent computing, how do you support the movement of data, or in general, how do you support big amounts of big data sets?
Yeah. There's a approach that we do now, and then there's an approach that we can take down the road, right? So the approach we do now is basically, because we're this automated control plane, there's a lot of information we already know. We know the cost of compute. We know how far the compute is. We know how much compute there is. The same is true for storage and network. We know the cost of transfer between cloud and on-prem, for example, because that's public information. We know the size of your data set. We also know where you prefer to keep your data. Many of our customers, because the simulations outputs create a lot more data than the input, they choose to bring in the data from on-prem and then keep it in the cloud, and then so they can use it again, or just pull down the portions that are relevant to the analysis, not all of the data, right? But I think we're moving towards a world where people want to operate in a multi-cloud or hybrid cloud model. But that means we have to have intelligence on where the data should be homed, where the compute is the cheapest, and it's quite possible you don't go to the cheapest compute because it's just way too far compared to where you want to keep your data. But because we know the cost of storage, we know the cost of transmission, it's a basic network optimization problem to figure out, how do you minimize the cost of the paths of moving data around, and that's our approach.
I see. So it means for large data sets, yeah, if you calculate the cost of moving the data and the cost of computing, do you foresee also a case or use case where you just move the computing infrastructure to the source or to the place where the data are existing, yeah, instead of moving to the cheapest computing site?
Yes, except we're not moving the compute. We're just pointing the compute to a slightly different location, right? Because if you have a data that you want to store somewhere, what we do is pull together the architectures from the major cloud providers, right? So odds are there is a region in your area where a good architecture for good value from a cost performance perspective will be useful for your workload. It may not be the best architecture possible, but it's one that balances distance and cost, right? And because at Rescale, we have all this information in our platform, it's very easy for us to work with you and say, hey, where do you want your data homed? Okay, you want your data homed in Japan or Western Europe. Okay, what are the cloud provider regions? Where the architectures are available? Maybe in some extreme circumstances where the data set is small and the performance benefit is much higher, it makes sense to run in US East. But most of the time, we're going to keep it local to the ones that are in Europe because that's where your data is going to be.
Mm-hmm. Yeah, exactly. Okay. Thank you very much once again for the very interesting presentation.